Consider the velocity field v vector is equal to a times x to the power 4 minus 6x squared y squared plus y to the power 4 times I cap plus a times 4x y to the power 3 minus 4x to the power 3 y times j cap in the xy plane, where a is equal to 0.25 meter to the power minus 3 second to the power minus 1 and the coordinates are measured in meters. Is this a possible incompressible flow field? Calculate the acceleration of a particle at point x comma y is equal to 2 comma 1. Solution. Here u is equal to a times the given expression and v is equal to a times the given expression. W is equal to 0. Concepts. The velocity field can be represented as v vector is equal to u times I cap plus v times j cap plus w times k cap. For a two-dimensional flow to be compressible flow, the sum of the linear strain rate along the given directions must be equal to 0, or we can say must satisfy the continuity equation, that is del u upon del x plus del v upon del y is equal to 0. This is basically the differential form of the continuity equation. Hence, we find the values of del u upon del x and del v upon del y by differentiating the terms u and v with respect to x and y respectively. On adding del u upon del x plus and del v upon del y, we get the expression equal to 0. Hence, we can say that the fluid flow follows the continuity of equation, and hence the fluid flow is an incompressible flow field for the given velocity field. Now, coming to the next part of the question, we need to know about the acceleration of the fluid particle. Concepts. The total acceleration, also known as the substantial acceleration of a fluid particle on a flow field, is given by the sum of the local or temporal acceleration and the convective acceleration. We can write ax, that is acceleration along the x direction, is equal to d v vector upon dt. This represents the substantial acceleration, and that is equal to del v upon del t, that is the local acceleration, plus u times del u upon del x plus v times del u upon del y plus w times del u upon del z. These are the local accelerations and convective accelerations respectively. We have ax is equals to the given expression. Since the velocity vector, there is no variable of the time t, hence del v upon del t is equal to 0. And since w is equal to 0, therefore the term w times del u upon del z is also equal to 0. So we have ax vector is equal to u times del u upon del x plus v times del u upon del y. Or ax can be written as, after differentiating both the u with respect to x and y and multiplying it with u and v respectively, and then adding it, we get ax vector is equals to a square times the given expression. On putting the values of x is equals to 2 and y is equals to 1 on the above expression, we get the following equation. On simplifying, we get ax vector is equals to minus 62.5 meter per second square. Similarly, we find the acceleration along the y direction, that is a vector along y direction. And similarly, we get a y vector at point 2 comma 1 is equal to 31.25 meters per second square. After solving both the equations, and we get the acceleration as at point 2, 1 as 69.8771 meter per second square.